Hello students, I am Shushmita Bhattacharya from the CBSE Department of Pathfinder. Today in this short session I am going to discuss certain important portions from the chapter Current Electricity. We know electric current is basically due to the flow of a number of electrons through the conductor. So if I write certain equation, I can say electric current I is equal to total charge Q flowing through a conductor in time t. So I is equal to Q by T. Now this total amount of charge can be correlated to the number of electrons that flow through the conductor. So let n be the number of electrons flowing through the conductor. So we can write I is equal to NE by T. Now this flow of current is possible through a conductor definitely due to a certain cause. So I is possible through a conductor due to a certain cause. So I just write due to a cause, right? Now what is the cause for it? The cause is nothing but the potential difference which is maintained. Now who takes the trouble to maintain the potential difference across the conductor? None other than a cell or a battery. So therefore there must be some relationship between the cause and the effect, that is between the amount of the current flowing and between the potential difference. The flow of current through a conductor is due to a cause. The cause is maintained by the cell or the battery. So what's the cause? The cause is nothing but potential difference which is maintained across the conductor by the cell or the battery. Now this potential difference is related to work done. So I repeat, the potential difference is related to the work done. Work done for what? Say work done in transferring a certain charge from one point to another in a conductor. So this potential difference and work which is is given by the equation V is equal to W by Q, where W is the amount of the work done in transferring the charge Q, and thereby we say that the potential difference across which the electrons have been moved is nothing but capital V, shown by this letter V. Therefore, from this equation it is possible for us to find out the unit as well. V is equal to the unit of potential is same as, so what is my intention? To find out the unit of potential, of course in the SI system. The unit of potential is equal to the unit of work in the SI system divided by the unit of charge in the SI system, that is joule for work and coulomb for charge. So we find that this joule per coulomb which is obtained from the above equation is as good as volt. So there can be one question where we ask that what is joule per coulomb or joule coulomb to the power minus 1 equivalent to? So it's equivalent to the SI unit volt, V-O-L-T. Now students, please be very careful when you write this word volt, do not write V with capital letter, because you are writing on the whole unit V-O-L-T, then it should start with small letter, else it should be simply, if I say it's a 6 volt, I can write 6 capital V then, where I am not writing the whole words. Again, we push off to another correlation between the cause and the effect, which is given by Ohm's law. So Ohm's law, it gives us that V is proportional to I. That means if the cause increases, the effect also increases, and vice versa. So from the proportional relation, we write it in the form of an equation which is V is equal to I into R. So this R is taken as the proportionality constant or constant of proportionality. So we have to ensure that all factors on which R depends must be constant. So let us find out what are the factors on which R depends. Number one, it depends upon the length of the conductor. I choose the length as L. So how does it depend on the length of the conductor? R is proportional to L. It depends upon the second factor, which is cross-sectional area. How does it depend on that? R is proportional to 1 by area. Apart from that, it also depends upon the nature of the material which forms the conductor, and lastly, it depends upon the temperature. Now students, you must have noticed that in the statement of Ohm's law, it's already mentioned that temperature and other physical conditions of the conductor remaining the same. Now what do we mean by other physical conditions? It's nothing other than length, cross-sectional area and nature of the material. So if these remain constant, then definitely we ensure that R remains constant, and if R is constant, V is proportional to I. That means Ohm's law is valid. I think I am clear till this point. Next is, if we just correlate the resistance with the different parameters on which it depends, we find that R is proportional to L, number 1. Number 2, R is proportional to 1 by A. So if I combine these two, what do we get? R is proportional to L by A. So once again, we can say that this resistance should be equated to a certain constant of proportionality rho into L by A, where rho is known as resistivity. So there is a certain correlation between resistance and resistivity, which is given by the above equation. Here we notice that this equation will help us to find out the unit of resistivity as well. How? We know rho is equal to R into A by L. See, the equation helps us to do so. R is given by the unit ohm, A is given by meter square, and length is meter. So ultimately the SI unit of rho comes out to be ohm meter. So the equation is not only helpful for finding out the relation between resistance and resistivity, it also gives us the SI unit. We find from here that the SI unit of resistivity is ohm meter. Now we want to study the variation of resistance for a conductor and a semiconductor with temperature. So what is it? The temperature of the conductor or semiconductor is varied. There will be certain variation in the resistance as well. So we want to find out how it varies. Now for a conductor, if the temperature increases, it implies the resistance will increase, which means the current through the conductor will decrease. If we push up to the semiconductor, things are a bit different. How? If the temperature is increased, the resistance will decrease, and so the current flowing through the conductor will increase. Next is, we have a cause-effect relationship given by Ohm's law. Apart from that, we can also pictorially represent the relationship between the cause and the effect. So, cause-effect relationship pictorially represented by a graph. We are talking about two graphs, say. In one first graph, we are plotting the potential difference along the y-axis. So, I write V along the y-axis and the current flowing through the conductor along x-axis. So, I is along x-axis. As a result, for any ohmic conductor, meaning the conductor for which Ohm's law is valid, you have a straight line. Now, this straight line will have a certain slope. What do we mean by the term slope? Slope means the difference of the y coordinate, that is delta y, divided by the difference of the x coordinate. So, children will first find out what has been plotted along the y axis. So, along y axis we find we have plotted here potential difference. So, we write V, and along x axis you have plotted nothing but the current. So, I write I. So, from Ohm's law we know that V by I gives us resistance. So, I repeat, the slope of this particular graph, that is VI graph, gives us the resistance of the conductor. So, it also indicates that if the slope S increases, it implies the resistance of the conductor is increasing. I will repeat, if the slope increases. Now, when I say the slope increases, we are basically concerned with say two different conductors made up of two different materials. And when we plot the graph, VI graph for it, we find in one case the slope is more than the other. So, whichever graph has more slope, the conductor corresponding to it should have more resistance. The same relationship can also be plotted where we choose the current along the current I along the y axis and the potential difference along the x axis. Once again I get a straight line, but this time the slope is given by I by V. We go back to now the different effects of current. We know in our syllabus we have heating effect of current. So, I discuss a bit from it. Heating effect of current. We know heat is a form of energy, and work and energy are correlated. Again, this work done per unit time is nothing but power. So, here we have found out that work is related to same as energy or related to heat, and work is once again related to power. We know power is equal to work by time. So, now if I consider the work to be electrical work, I can bring the concept of potential here and I write work is equal to potential V into Q divided by time. Now, this Q by T is nothing but electric current I. So, I make the substitution and get it as V into I. So, from here what do we understand? That electric power is equal to potential difference V into current I. Now, this is also equal to energy by time. So, if I take this energy to be same as heat energy, I can write that heat evolved when current I is flowing through a conductor across which a potential difference V is maintained, then heat is equal to V into I into T. Since we know Ohm's law gives us V is equal to I into R, therefore, making proper substitution using Ohm's law in this particular equation, heat is equal to VIT, we can have the different forms of the heat evolved in a conductor while current is flowing. I repeat, Ohm's law gives us V is equal to IR. So, if I want to remove this term V from here, what do I write? I write or I substitute IR. The moment I make the substitution V as IR, what do I get? I get I square RT as the amount of the heat generated. Similarly, if I want to get rid of the term I, then I write I is equal to V by R from Ohm's law, and therefore, heat generated becomes equal to V square by R into T. I think this video had helped you to have the basic correlation between the different terms that we use in current electricity. Thank you, students. I wish you all the best for your forthcoming examination. At the same time, wish you a very happy new year.